Hello, welcome back to another episode of Maths with Hamblin with your beautiful host, Hamblin. And today, my boys, we're going to carry on from what we did last episode with polynomial division, and we're going to look at that and see how we can use it to help us solve for all the roots of a cubic. So we're basically solving cubics fully. We've finally got there. Okay, anyway, let's get into it, my boys. Okay, so a quick review from last episode. What we did is, say we had some cubic polynomial, and we knew that if you plug in some number, for example in this case 5, and then you output 0, then we can use the factor theorem to deduce that x minus 5 must be a factor of that polynomial, or in general x minus a for f of a equals 0. So then we can write that our function equals x minus 5 as a factor times some other factor that we want to figure out, because then if we know this factor and this factor, then we can solve for all the roots of our cubic. And we did that. See, if I divide by x minus 5 on both sides, then we get this equals our mystery factor, and then we learned how to do this with polynomial division, so we can figure out what our mystery factor is. And we're going to use that process there to then fully factorize cubic polynomials and solve for all their roots. Okay, so let's go through an example. Okay, so let's go through this first example here. We have the same function as last time, thought, recycling. We have f of x equals 2x cubed minus 7x squared minus 14x minus 5. And our first part is to show x minus 5 is a factor of f of x. Okay, so pretty clear how we do this, the usual business. We just chuck in f of 5, and we hope, and if it equals 0, then we conclude by the factor theorem that x minus 5 must be a factor. Okay, so we get 2 times 5 cubed, minus 7 times 5 squared, minus 14 times 5, minus 5. And you can put it in your calculator. This, in fact, does wind up equaling 0. So we get f of 5 equals 0, then we can conclude that x minus 5 must be a factor. Okay, so that's the first part. Now we know one of the factors, we can then perform polynomial division to get the other quadratic factor, and from there we can solve f of x. Okay, so let's do that. Okay, so now we know that x minus 5 is a factor. Let's do polynomial division on this thing by x minus 5. Okay, so remembering our method, we write down the cubic we want to divide by. Then we write down our factor, and then we need to think what coefficient in front of this factor, when we subtract it off, will cancel with this first term here. And in this case, if we subtract 2 lots of x squared, hope you can see that, sorry, then this will expand to minus 2x cubed and then plus 10x squared, and this will cancel with the first bit of this, and then we'll be left with this positive 10x squared, which will carry over to the next line. So these cancel, and then carrying over the positive 10x squared, we get 3x squared, and then we'll keep writing down the rest of it. And let's write down our factor again, and then we play the same game again. We think what coefficient here, when we subtract it off, will cancel with this first term. And in this case, it is correct. It's minus 3x. So minusing 3x, we get minus 3x squared, which will cancel here, and then plus 15 lots of x, which we can add to this, and then we get x minus 5. We carry over to the next part. And then we just need to think, okay, then this minus what coefficient of this will cancel down with this first term here, and it's going to be minus 1. So we get minus x, which cancels with this part, and we get positive 5. And actually, that all cancels down to 0. And if you remember from polynomial division, when we end up with exactly 0, we know we found a perfect factor of our cubic. And we can see the factor by just looking at these terms here, and then flipping the sign. So if I just rub this out quickly, wow, yeah. So what we found is our other mystery factor is 2x squared plus 3x plus 1. So that's pretty cool. So that means we can rewrite f of x as x minus 5 multiplied by this other factor. And of course, you can multiply this all out, and you'll see that you do in fact wind up with this. Okay, and now the next part, solve f of x equals 0. Okay, so now we've got two factors here, and they equal 0. It's very reminiscent of quadratic factorization, and it's pretty much the same deal, and you'll see what I mean. So let's copy down this so we can write it as an actual equation. Okay, fantastic. We've got x minus 5 times this lovely quadratic factor equals 0. And now we think, okay, well, it's either this or this must equal 0 to make the whole multiplication equal to 0. If we think, well, if x minus 5 equals 0, then x equals 5 is going to be a solution. And now we need to think 2x squared plus 3x plus 1 equals 0. Okay, from that we can use the method for factorising quadratics with a non-1 coefficient for x squared. Okay, so if you remember how to do that as well, a lot of methods in this video. Then we write down 2x and x, because 2x times x will be 2x squared, times blank, those are our mystery numbers, equals something else, and we want the result of that to equal 3x, and we want these two mystery numbers to multiply to 1. And in this case, it's actually really easy. If we have 1 and 1 here, then 2x times 1 equals 2x, x times 1 equals x, they sum to 3x and they multiply to positive 1. So in fact, God, I just keep throwing my rubber places, I really should put it up there. Anyway, so from this we can then conclude that 2x plus 1 is a factor and x plus 1 is a factor, so that's brilliant. Which means we can rewrite this quadratic as 2x plus 1 times x plus 1 equals 0. And then from here we can just do the usual business of factorisation. Well, from here we get x equals negative a half, and from here we get x equals negative 1. So boom, there we go, we've solved for all of the 3 possible roots of a cubic polynomial just using polynomial division and factorisation. X equals 5, x equals negative a half, and x equals negative 1 for the case of this cubic here. Okay, let's go through another example. Okay, so my boys, this next one is pretty epic. We've got a cubic polynomial function here, x cubed minus 7x squared minus 4x plus 28. First part is show that x minus 7 is a factor of f of x. Okay, usual business, let's use the factor theorem. So from this we can get f of 7, if that equals 0, then we conclude that x minus 7 is a factor. So let's compute f of 7. That's going to be 7 cubed minus 7 times 7 squared minus 4 times 7 plus 28. And then you can chuck that through your calculator. You'll wind up with 0. And from that you can conclude that x minus 7 is indeed a factor of your cubic polynomial. Okay, boom. What's the next part? B. Write f of x as a product of 3 factors. Okay, we've only written f of x as a product of 2 factors so far, a linear factor and a quadratic factor, but no problem with that. As you saw from the last example, we can rewrite the quadratic factor as a product of 2 more linear factors. So then if we chuck that back in to the expression with f of x factorised, then we'll get 3 separate factors that equal f of x. So let's do that. Let's do polynomial division with our lovely little function and x minus 7. Okay, so let's use our method. We'll write down the cubic. We'll write down our factor. Okay, right, now we need to think what coefficient here. You subtract it, it cancels with this first term. It's going to be minus x squared, as when you expand this you get negative x cubed, and then plus 7x squared, and the x cubed and the negative x cubed will cancel, and then you get the straggling plus 7x squared, which will actually perfectly cancel with this 7x squared, so that's cool. So then we carry it over, we're left with negative 4x plus 28. Okay, that's brilliant. Then we write down x minus 7 again, and then we think what coefficient here, when we subtract it, we'll wind up with positive 4x, so we can cancel with this one. And it's actually going to be plus 4, because when you expand this out you get plus 4x, which cancels with this minus 4x. And in fact, you'll also get the minus 28 from expanding this, which will also perfectly cancel with this. So we wind up with exactly 0, and then we wind up with 0, which means we know our polynomial division has worked, and we've found the other mystery factor, which in this case is x squared minus 4. Remember, we need to flip the signs here. So x squared minus 4, that's a nice and simple quadratic. Okay, so we've found a linear factor, x minus 7, and a quadratic factor, x squared minus 4. So that means we can rewrite f of x as equivalently as the product of this factor times the product of this factor. Okay, so part B, we haven't answered part B yet, have we? We need to write it as 3 separate factors, but that's no biggie, because we can rewrite this quadratic as 2 factors in its own right, so we'll wind up with 3. So let's do that. So this equals x minus 7. Okay, now this is a bit of a tricky factorisation, because we haven't got an x term. We're going to have to use our brains a bit. So we're going to have to think of 2 numbers that when you multiply them you get negative 4, and then you add them you get 0, kind of, because there is a coefficient of x here, but it's equal to 0, kind of. So we need to think of two numbers that they add to 0 and they multiply to -4. And if you do a little bit of thinking for a second, you'll come up with 2 and -2, because when you add them you get 0, and when you multiply them you get -4. So this can be rewritten, this part can be rewritten as x minus 2 times x plus 2. Okay, that's brilliant. And if you don't believe me, of course, you can multiply that out and you wind up with x squared minus 4. So brilliant. We've answered part B. We've rewritten f of x as a product of 3 lovely factors here. Now, part C tells us to solve f of x equals 0. And this, oh my god, is real easy, even easier than last time. Because we can just look at each of the factors and think, well, okay, one of these needs to be equal to 0. We can just read off the roots. We either get x equals 7 from the first one, x equals 2 from the second one, and x equals -2 from the third. And boom, we've solved for all the roots of our cubic polynomial. Absolutely fantastic. Okay, so my boys, that'll be that for that video. I hope you very much enjoyed that. I hope that was helpful in any way, shape or form. And if you need some more practice for that, then there's just an infinite amount of past papers on the AQA website or whatever exam board you're using. And those type of questions tend to be worth a lot of marks. And as you see, they're actually quite easy and simple to do. So they're really, really good for your grade. Anyway, so yeah, thank you very much for watching. Please consider subscribing to this poor guy here. And yeah, I'll see you in the next one, boys. Thank you very much. Bye.